Alright, so here's another video, a few more problems. I was going to do number 35 and then realized it's not a good problem to introduce a concept with because it doesn't work out nicely. So I thought I'd go with the example problem in your book, but why not show it to you anyways. To solve for one of these, I cannot isolate e because they're to different powers. So the only way to do it is to factor, and we could just factor this straight up. Or we could do u substitution, which you guys have already learned. So why not review a little u substitution? We all love u. So let's do let u equal e to the x power. So then we have u squared minus 4u plus 3. And then I can factor that nicely. Right, u times u and a negative 3 and a negative 1. So then I get u equals 3 and u equals 1, but I'm not solving for u, I'm solving for x. So we need to replace u with what we know u is equal to. E to the x equals 3 and e to the x equals 1. This one's pretty obvious. Anything to what power is 1, right? Anything to the 0 power is 1. That answer I don't need to worry about. But this one is rather difficult. So the way to solve this is, again, I can't get my bases the same. I have to put it in log form. So ln of 3 equals x. And just push buttons on my calculator. Handy dandy calculator. ln 3, 1.0986. That's a nice little number. And there's my other answer. X equals 1.0986. And again, I could store this in my calculator and double check it. But right now I actually have it as my answer in my calculator. So if I just do e to the 2 times answer minus 4 e to the answer, second negative sign, by the way, there's your answer key, and then into parentheses plus 3, and I know my answer should be 0, and voila, it is. So that's how to check that. So that's pretty nice. Those both work. Or actually, I know that this one works. Anything to the 0 power is 1, so 1 minus 4 plus 3 is 0. I know that one works too. All right, now this problem, the way to solve these is you have to condense it first to a single logarithm on this side. So what does the plus tell you? It tells you to multiply. So we get log base 2 of x minus 1 times x minus 3 equals 3. So then I can just multiply that out and I get x squared minus 4x plus 3 equals 3. And this right here is where everybody gets stuck. But all you have to do is, if I can't solve it in log form, I take it out of log form. And this means 2 to the 3rd power equals all that junk. 2 to the 3rd power, also known as 8, equals x squared minus 4x plus 3. And then I'm back to chapter 1 again. Set it equal to 0 and factor. If it doesn't factor, you're stuck with quadratic formula. Minus 5. Does this one factor? 5 and 1. X minus 5. X plus 1. My answers are 5 or negative 1. So then I look back at my original problem and remember that the domain of a log is that this parentheses here could never be negative. So if I put in these answers, will that make the parentheses negative? 5 would work, right? 5 minus 1 is all good, and 5 minus 3, actually, that works just fine. But negative 1 is an issue. I can't put negative 1 in either of those parentheses. So this is what we call an extraneous solution, and 5 is the only actual answer that works. Make sure you guys check your answers. How would I do this one? How do I condense a subtraction problem? That's division. So I get log of 2x minus 5 over x minus 3. And again, how do I solve it when I can't solve it in log form? I need to take it out of log form, and this is a common log, so we assume that the base is 10, and this means 10 to the 1 power equals that stuff. So then how do I solve that? Multiply this side by x minus 3. I get 10x minus 30 is 2x minus 5. Paper keeps moving. And then, what do I get? 8x equals 35. No, that's a negative 5. So it equals 25. X is 25 over 8. Again, we need to double check that this number won't make either of these parentheses negative, and it won't, so that is my answer. All right. Same thing here, except that there's log on both sides, which makes this much nicer. So when I condense this one, I get the square root of 3x plus 6, log of that over the square root of x plus 1 equals the log of x. And if the log of this equals the log of that, then this equals that. And then you could just square both sides and get 3x plus 6 over x plus 1 equals x squared. And multiply this over and solve for x that way.